So what happened when we have a number divided by 0? If you remember, that is something we cannot do. That's on the term undefined. You cannot do the division by 0. When we're talking about limits, this means that this limit approaches either positive infinity or negative infinity. But for this particular exercise, for this activity, we are not doing limits at infinity, so we have to write for this dne does not exist. If we really want to find this limit, this would be like something to positive or negative infinity, but that is out of the scope of this particular activity, so you just have to write d and e. That is okay for well assigned. Okay. What about the third one, the e? Limit of my function f of x times x to the cube as x approaches to. Well, here again, I don't know how my graph function looks, so I have to split that up. Limit of x cubed as x approaches to multiplied by the limit of my function f of x as x approaches to. You see? The second part here, I will find it graphically because I have the graph here. But this one here, I will do that analytically because I don't have the graph. You see? So first, I will do. So for the first one, because I know that the function has a graph like this, I know that this is a continuous function that has all real numbers as the main and doesn't have any kind of jump, or it is not defined in pieces. This is not a piecewise function, and this is continuous for all real numbers. All I can do here, just here, because that is true, I can just substitute. Instead of writing x, I will write 2 cube. Okay, that is the first limit. And the second limit, I have to take a look at the graph and see what happens when my number x approaches 2. The number 2 is here. As I approach here and here, I'm approaching what number? I'm approaching the number 2. So that would be 2 to the cube is 8 times 2, that is 16. Okay, 16 here. Now the last one. Here I have the limit of this function, square root of 3 plus f of x. And that is again a function whose graph I don't know. Because I don't know this graph, I want to try to find a way to do this. Okay, by using the rules or the properties of limits. So I will do that one here. First, remember that I can rewrite a square root as an exponent. That is what I will do first. So I will rewrite this as the limit as x approaches 1 of. I will no longer write that square root. I will write it as exponent. That exponent is 1/2. Okay? 3 plus f of x. You see? Now I have another property of limits that tells me that the power of a limit is the same as taking the limit and then the power. So I can rewrite this as the limit of 3 plus f of x as x approaches 1. All of that to the 1/2 power. You see? Now that way I got rid of that square that was a little bit troubling in that problem. But still, I don't know the graph 3 plus f of x. What I can do is, again, rewrite this. The way I will rewrite this is split that sum into two different limits. The limit of 3 as x approaches 1, and the limit of f of x, again as x approaches 1. This one here is a 1. Here, there's another property you need to remember. What is the limit of a constant? This is a constant because the number 3 doesn't have an x there. So it doesn't matter what number you are approaching, this will always be 3 because that is just a number constant. It is just a constant. For the second part, I have to find the limit with the graph of f of x. I have the graph here above, and it is as x approaches 1. Here's my number 1. What is happening from the left side, from the right side? I'm approaching this point whose y coordinate is 1. So here's 1. And all of that, square root. What is 3 plus 1? 4. What is the square root of 4? 2. You see? For this one, the answer is 2. Okay. Right, now here. Suppose that the limit of f of x as x approaches a is -5. And the limit of g of x as x approaches a is 0. Then we also have the limit of the function h of x as x approaches a is 8. Find the value of the given limit. If the answer does not exist, enter the e. So here, again, I will rewrite this as the limit of f of x plus the limit of h of x as x approaches a and as x approaches a. You see? And what is the first limit? I have it here. That is -5. What is the second limit? I have it here. It's 8. What is -5 plus 8? That is 3. So the first limit is 3. What about the second one? We have the limit as x approaches a for the function x of f of x at a square. So again, I have to take that exponent out because I don't know this limit. This limit is not given here. But what if I take that exponent out? Like this. As x approaches a. I now know the limit of f of x, which is here. That is -5. The square. What is a negative number square? Positive number. 5 times 5, 25. So this limit approaches 25. Third one is pretty similar. I have to rewrite this exponent as the limit as x approaches a of my function h of x. Instead of writing that cube root, I will write it as 1/3 here. And then just as I did in the last step, in the last exercise, I will take the exponent out. You see? Writing it out. And then inside I'm just writing the limit as x approaches a. Okay, and what is that? I have it here. That is 8. So I have 8 to the 1/3. But remember, a 1/3 is just the cube root of 8. What is a number that multiplied by itself 3 times gives me 8? That is the number 2. That is the number 2 here. Okay, number D. The limit of 1/f of x. Again, I don't know this function here initially, but I can apply the properties of limits to get to it. Yes, if you remember, whenever you have a number in the denominator, you can rewrite that number as an exponent, as a negative exponent. So I would rewrite this as the limit when x approaches a of the function to the -1. Okay, let me make some space here. I will continue here so that here. Okay, here. So again, I will take the same property, limit of f of x as x approaches a, and then the -1 at the end. This limit I have inside those parentheses, I know it, because it was given here, and that was -5. Here, that is -5 to the -1. And now I can just rewrite this as the original form, as 1 over -5. That is the answer to this limit.